Hi students, welcome to my videos on process plant operator. And today we have with us my MTech student Rajat Chauhan, who is doing presently masters. Uh, in the second year now, he is presently doing internship in Zeppelin India Private Limited, and from there he is doing project of crisol separation and using various simulation softwares. And I thought to share you some good information through the student, because currently he is doing internship in the industry. Maybe he can share much more live informations of what happens and what kind of work they do and what kind of job the student deliver. These are the things we are going to discuss. And today we thought of sharing you some information about the piping and instrumentation diagram. Maybe he is going to, give a brief about what he is going to deliver, and by giving some example. Introduce Rajat. Can you brief our students what you're going to deliver?
Yes, sir. So today in the video, I would like to explain you all that how can we prepare the piping and instrumentation diagram, and also how to read it with the knowledge of the uh, data which is required to read piping and instrumentation diagram.
Yeah, maybe I will, because the student might be nervous in presence of faculty. I thought to leave him for a while here to deliver his talk. So please don't mind. I'm going to go out at this moment, and he is going to continue for the present class. Later on, we can share much more videos related to this. And thank you, Rajat. Now it is up to you.
Thank you, sir.
Yeah.
So yeah, hello guys. So let's start with our video, piping and instrumentation diagram. So first of all, let us understand what is piping and instrumentation diagram. Piping and instrumentation diagrams gives us the information about each and every pipe which is present physically in the plant. It gives that what kind of material is being used for the pipe preparation, and what kind of material we are dealing with to transfer that material from one part of the unit to the another part of the plant unit. This PNID is generally most commonly used by the process engineer in the chemical world. Now, if we are doing something, it must be offering something to us. So let us understand what the PNID offers. So PNID offers the key piping and instrumentation detail, control and shutdown scheme, that by using PNID we can plan our shutdown, that at what point of time we can do the maintenance of some equipments in the plant. Likewise, we can have an idea that at what time we can shut down the plant through PNID. Now, safety and regulatory requirements are also there in the PNID. All the control safety valves are present in the PNID. So by that we can regulate the requirements of safety through PNID. After that, what are the basic documents required to prepare the PNID? So there are the three basic documents which are required. First of all, the process flow diagram is required. It is a very basic diagram of the plant. It includes the capacity of the pump, the instrument which are being used, and the flow directions is there in the PFD. After that, after we have the PFD, the two main major documents which are required to prepare the PNIDs are process data sheet, PDS, and piping service index, which is also called as PSI. Now what are this PDS and PSI? We will explain it in the further slides. Now so what is process data sheet? Process data sheet is a document which includes the major parameters of the process. That means of the process and the equipment also. That means the size of the equipment, the capacity, the material of construction that is being used to fabricate the material, fabricate the equipment, the insulation type, and that insulation, what how much thick that insulation will be for that pipe. This all details are in present in the process data sheet, which is used by the process engineers to prepare PNID, because this all data will be there in PNID. So we must prepare this PDS first, and then we will go to the next step, which is preparation of piping service index. So piping service index, it contains about the fluid, that the fluid which is flowing, what type of fluid is there, and what type of piping is needed to transfer that fluid efficiently or efficiently from that pipe. So piping, let me explain you the data which is present in the piping service index. So the piping service, the fluid which is being handled, we can't use the full name of that fluid. We have the code, fluid code, to represent a particular type of fluid. So this code is represented by the 3 digit, which is abbreviated as A1A, A1K, A1L, B1A, A1H, likewise, etc. These are some of the abbreviation for the fluid code. Now what does this abbreviation have? So indicates, the first letter indicates the pressure rating, that at what pressure that pipe is okay, that pipe can handle. So that is the first letter indicating. A represent these are the data. You can see on the screen that these are the data which indicates the pressure rating. A represent this, and B represent 300. Likewise, these are the pressure ratings. The third letter indicates the type of material. What type of material is being used? We can say MOC. What is the MOC of the pipe? MOC means material of construction. So the third letter indicates the type of material. A represents the carbon steel, B represents the alloy steel, G represents PVC. Likewise, this is how we can represent the fluid code. Now there is also a number in between this first and last letter. This number represents the difference in specification or different spec of the material used. Now we have this carbon steel. Okay, till what corrosion allowance this carbon steel is used? In some fluid flow, we can use 1.5 mm seamless corrosion allowance. It will be okay to use that. But in some fluid flow, we can't use this. We must use 2 corrosion allowance, which is allowed till 2, and which is also welded. So according to the requirement, this specification changes, and this all data is also used in the PNID during the line number. When we draft the line number, this data are very important to draft the line number, because this data will be there in the line number. After the piping service index is done, we can start now our PNID preparation. So for PNID preparation, there is no general general data or general some symbols. Every company differs their symbol according to their need. Some company needs the symbol process line like this, like a fully dash line, and some companies need the process line as the dash line, which have some breaks in it. So likewise, according to company's need, we need to prepare the PNID which is required, which is or desired by the company. So these are the symbols for the lines. Next, we will see the symbol of piping. These are some of the symbols which is used in the piping or instruments, equipments. I would rather say. Now after this piping symbol, these are the valve symbols which are used in the PNID. There is a three-way valve. This is represent as the butterfly valve. This is the globe valve. Likewise, these are the symbols of valve which are used in PNID. Now this is the very important part of the PNID, control valve. Control valve represents one of the major step. It is one of the very major thing in PNID to represent. So we must know that what type of control valve is used for what kind of controls. So these are the control valve symbols. These are the instrument symbols. Now for the instrument symbols understanding, we must understand what this two letter represent. So for this two letter representation, let us move to the next slide. Instrumentation identification letters. So the first letter of the instrument represents the this all parameters. So we have what we have. We have FT. First letter is F and the succeeding letter is which is T, transmit. So what does FT represent? It represents the flow transmit or flow transmitter. This FT represents the flow transmitter. Okay. So likewise, we also have TT. So if we want to see what does TT represents, TT represent temperature transmitter. We also have other examples like PG, then PT. So likewise, we can identify the instrument letters and what does it represent. Now also in this, if we want to put the informations which is also showing locally and also showing on the panel control room of the chemical plant, so this is the symbol which is used for the DCS, that is direct control system, or we can say the panel, control panel. If we want to show in the PNID that this rating is also showing on the panel, we will use this symbol. Okay, this is also one of the very important instrument symbol of PNID, which is interlock. Moving on the next slide. After the company has decided how their PNID should look like, they will provide this legend sheet which include all of the symbols: control valve symbol, control symbols, piping symbols, all type of symbols they need in their PNID is presented in this legend sheet. This legend sheet is with the process engineer while drafting PNID, and at any point of time the process engineer can refer this legend sheet for their drafting purpose of PNID. Now the very important step or very important part of PNID is to give the line number or line nomenclature. What is line nomenclature? So let us understand line nomenclature. So in line nomenclature, it consists of 6 parts. The first part represents the line size, the second part represents the material flowing, third part we have already understood in the PSI, which represents the line pipe specification. The fourth part is also divided into 2 parts. Let me make you understand that these first two numbers represent the unit number, that at what unit number it is the line is present. So if there is a chemical plant, a big chemical plant, there must be number of units. So we can understand from here we can understand that this line is presented at the 10th unit, which is given as the number 1 line. So first line of 10th unit have this specification, this fluid flowing and of this size. Likewise, we can from the line nomenclature we can understand that what is the specification of the line and what material is flowing through it. After the line number is given, the insulation part is there, that what kind of insulation is done, either it is cold insulation or hot insulation. So H represent the hot insulation, and if we want to represent the cold one, we can use capital C for the cold insulation. And this is the insulation thickness which is represented at the last. Now again, this is not the general rule. According to the company, the sequence may get changed from one to another. There's line spec can go from third place to the fourth place, and line number can be from the fourth to one. Likewise, we need to adjust according to the company's need. So after the line nomenclature and the data which we have learned from the first slide till this slide, now I think we are ready to read the PNID. So let's try to read this storage tank PNID, which I will be using for the explaining purpose. So let's read this PNID. So I have taken the storage, I have taken this PNID for storing of the process liquid for 1 or 2 days. So this process liquid, you can see this process liquid is coming from the plant. This is known as flag. This flag represents from where it is coming from and from which PNID it is coming from. So this is very important flag with a very important information, so we can understand that from where it is coming and to where it is going. This is the line number nomenclature. We have already understood it in the previous slide. So we will see this is the we can see this is a storage tank. Now these are some of the nozzles which are they are present at the surface of the tank. These are nozzles for the connection purpose. What is this? This is the manhole. There are some manholes given to the storage tank, which to see physically under the storage tank, that sometimes that what is going on, or like for the maintenance purpose, this manhole is given to look into the storage tank. Now these are some instruments which are applied or which are jointed to the tank. Now let us understood this instrument. Now I have already explained you this. This symbol is used to represent the DCS control. To use that, this control is also displayed at the control panel. So what is this LT? LT represent the level transmitter. It is a rod type, like the rod or the radar. It is a radar type. See, it is written here. The radar is in the storage tank, and it will be continuing monitoring. It will continue to monitor the level of the fluid inside the tank, which will be showing at the control panel. So like this, at the panel we can get the level of material at any point of time. So level transmitter is used to monitor level of material in the storage tank at any point of time. Again we have this LS. Now what is this LS? LS is the level switch. So one may ask that if there is an LT, what is need of this LS? Generally this question arises. So the LS is not something which will continue to monitor the material level of material inside the storage tank. It is the instrument which will just trigger at some point. So whenever the LS triggered, it shows that the level reaches this part of the storage tank. Here we can see that it is generating an alarm or generating a cause or at high level, first LS. The second LS is generating an alarm at high level. So whenever the high level reach, this LS will generate an alarm at the control panel, and control panel then the engineer which is there at the control panel will immediately call the operator to switch off or to switch on the drain part or the collection pit part, so that the level can be reduced in the tank, so that it cannot overflow. We can manage it by opening the uh, pit. So after that, the level switch is also presented at the bottom. Why it is needed at the bottom? Again, for the same reason. If the level is low, it will generate an alarm, and it will then the engineer call the operator and will say the operator to open up this valve so that material can come into the tank, and the process flow then will resume. So now let us understand the pump assembly. So for the pump assembly, every chemical engineer or the process engineer use 2 pump at a time. It is not mandatory, but it is I would say it is good to use 2 pump, because at any point of time in chemical industry you would not know what can occur. So one standby pump is must to be used. So in the pump assembly we have this equipment. It is known as strainer. Now before entering to the pump, before the material which is flowing, before entering to the pump, it passes through this strainer, which will remove all the physical impurity. Because if there is let us consider, if there is a physical impurity is present in the tank and that fluid is passing through the pump, it may cause the damage to the impeller. So we first need to remove that physical impurities. So for that we are using this strainer before the pump. After it is strained, after the fluid is strained, it is transferred to the pump, and the discharge line will be containing this NRV valve. This type of valve is called as NRV. NRV means non-return valve. It will prevent the backflow of the fluid. If the fluid is coming back, if it is not generating the proper pressure, the fluid will come back, but this valve will not allow the fluid to come back. So for the safety purpose, if it is required to provide the NRV at the discharge point of the pump. So again, for the same pump also the assembly would be same as the same pump, because at a time only one pump will be in the working condition, the other pump will be at the standby position. If something occurs to the first pump, or we want to do the maintenance of this first pump, the second pump will be working and we can stop this valve, so that material will not flow into this pump, and we can open this valve so that material will flow from this part to the directly to the second pump. So likewise we can control the flow of the material through the valves. After the pump, we just need to transfer it to the desired position or to the next part of the plant. Now again, what is this? This is the filter which is used here. It is not generally recommended, but some of the companies may recommend that I want to send the purified material to the next plant. So some of the company may say that we want filter at the discharge point. So this the process engineer who have made this PNID had given this filter at the discharge point, and these two flag represent to what plant this material is going. and at that plant is represented in which PNID number. So likewise we can understand the PNID. Now the main one of the main thing which is present in the PNID, it is interlock. So for the interlock we have this table. We have this table in the PNID. It is here, you can see. For every interlock used, that interlock is listed in this table. What does it cause and what is the effect of that cause? It is represented here. So let us understand the first interlock. So if practically if we look into this tank, if let us think that it is at the high level, what precautions are you gonna take as a chemical engineer if the tank is at the high level? It's very obvious that we will switch off this valve, and we will transfer the signal to the previous PNID, previous unit, that please switch off the pump from where this material is coming from. Correct. So if it is switch off, this the high level will not get overflow from this tank. Correct. So this interlock is used to stop the pump which is present at the previous PNID or previous unit of the chemical plant. Now if there is an high level, we have this interlock. If the level is low, what is the effect? If the level is low, we can't transfer the material from this pump because there is no material into it. The level is very low. If there is no material, what we will transfer? Nothing. And if the level is low and pump is in working condition, it will damage the impeller. The cavitation may occur in the pump. So it is required to switch off this pump when the level is low. So how does this interlock work? It transfer the electrical signal into the mechanical signal. So for the every low part, we have the interlock number 02. See, here we have 02 number. Here also at the low level we have 02 number. So the line which is coming out from this DCS symbol, it represents the cause. That this is the cause. Low level is the cause of this interlock, and this interlock will have an effect on what the arrow going in will represent the effect of that interlock. So the effect of that interlock is it will switch off this pump. And how can we know it will just switch off? That information is provided in the table. So 102, low in storage tank 001. What is the effect? Stop this pump. Correct? Understood, guys? So I hope you understood the basic of PNID. And to read the PNID, you can see this is how the basic PNID look like. At the end we have all the specification of the PNID which are present in this particular PNID. All the equipment are listed and what type of size, what is the capacity of that equipment, what are the operating conditions, like the what are the design condition, maximum design conditions are there, temperature and pressure, and what is the material of construction. That this all data is also present in the PNID at the bottom of this PNID in the form of this table. At the right hand side bottom we have the company name or the consultancy name which has drawn this PNID, and here the client name which have given the project to that consultancy to draw the PNID of that plant, and we have this drawing number which is also known as PNID number. So this is how a general PNID look like. So I hope you guys understand that how to prepare the PNID, what are the important data or materials which are used to prepare the PNID, and after the preparation of PNID, what are the how can we read the PNID? What information we should have to read the PNID? I hope you understand. And if you guys have any question, any doubt, we are here to answer you. You can comment in the comment section below, and also I will upload this link for the PPT. You may refer from PPT. You can download it from there. So yeah, thank you guys. Thank you.